So hi everyone, we are group 1 and we'll be presenting our assignment 2, which is group assignment. So we'll be developing a model which will help the calls in decision making and further business operations. So let's continue with the presentation. So we are group first of 3 members who are Ashok Paudel, Chandrasekhar Dungana and Miss Aurabel Base. So let's start. So we'll be following these data pipelines which contains data collection, data ingestion, data wrangling, data processing, data analytics, and data visualization or output. The above 4 parts are data processing, and the remaining 2 are the part of data analytics. So the first step is the data selection. The data set which we are using is from the Coles online grocery listing across Australian postal codes that provides publicly available product details like prices, brands, sizes, stock, and promotions for analyzing price trends and regional differences. And the data features which we'll be using for the data analytics are the categorical data includes the category, subcategory, product group, brand, state, and city. The numerical data includes the columns such as retail price, unit price, package price, and the other data includes run date, is estimated, and the discount flag. The research questions which we will be including in our project are there are four in total, which are which product category generates the most revenue, and the second one is which brands earn the most and how do similar brands compare, and the third one is how does revenue differ by Australian state, and the last one is can we predict product revenue with machine learning. So the second step is the data ingestion, which defines that how we are transforming our data into meaningful into the form where which can be further processed. So we loaded the Australian grocery 2022 September CSV dataset from Kaggle, which has 480,000 rows and 22 columns in total, into a Python and took a small sample of 40,000 record for further analysis without any cleaning or changes. The later process are data wrangling and processing. So next will be continued by my friend.
Yeah, thank you, Saurabh. Now I'm going to discussing about data visualization. So first plot represented the revenue generated by each state, and as you can see on the plot, South Australia and Queensland are the highest earning state of around like 40,000. How much? 40,000 AUD, which is followed by Western Australia, Victoria, Australian Capital Territory and Tasmania, which are all at similar kind of values, which is slightly lower than South Australia and Queensland. And as you can see from the graph, the Northern Territory has the lowest revenue of around 20,000 AUD. And then second plot shows that the revenue generated by each product categories, and as you can see, the pantry is the top grossing category with a revenue well over 140,000 AUD. And drinks, dairy, eggs, and freeze and meat and seafood are the next highest categories. And the bakery and fruits and vegetable have the lowest revenue of around 20,000 AUD. And then third plot represented the revenue distributions according to discount flag. The violent plot shows the distribution of revenue for transaction with and without a discount. With and without a discount. So the discount flag showing by 0 shows that the revenue which have like low and consisting revenue, and the transaction with a discount flag, which is represented by flag 1, have a much wider distribution, with some transactions generating higher revenue, so which suggests that the discount often apply to the larger sales. And the next slide, please. And this slide shows the top 10 brand according to revenue generated, and which is the like the bar charts rank the top 10 brands by revenue. And as you can see from the plot, the Coles is the highest earning brand with revenue close to 45,000 AUD. and remaining branch from R nodes and to Victoria's, having like revenue value clutter around similar kind of values of around like 10,000 AUD. And next slide, please. And for predictive model, we implemented linear regression and decision tree model. And as you can see from the result, we obtain R2 squares of values of 1 and 0.99 for linear regression model and decision tree, which is also justified by the plot. As you can see, there is a plot which highlighted the actual revenue and the predictive revenue, and we got a straight line which represent that the actual revenue and predictive revenue are very much similar to each other. And then next. And in order to find the best cluster value, we have implemented ALBO method and silhouette method, and we get a cluster value of k we get the cluster value of 3, which is showing by the ALBO method. And next slide, please. And the silhouette method. And now to continue the slide onwards, I will request Chandra.
Okay, so I'll explain what the clustering means and why it's necessary. Clustering is necessary. The clustering is just grouping the data in terms of their features. If they have very huge variance between different groups, and if it's effective, then that's the point when we cluster the data. And sometimes we might not even need to cluster data because they have like same amount of variance between them. Let's say if the data is like 10, 20, 30, 40, and the variance is 10, we don't have to cluster them because but sometimes the variance might be huge. For example, let's say the best example that I can give is like clustering students based on their exam performance. Let's say the top 10 students achieved more than 80%, but from 10 to 20, they just got 50%. That means analyzing both of those student groups in the same data set would not be that effective than analyzing them dividing in different clusters. Next slide, please. Next slide. Yeah. So in our analysis, we have divided our data into 3 clusters. First cluster would be discount-heavy customers, meaning the customers that are discount-driven. They just buy products when they are in discount. The cluster 2 is low-price products with low revenue customers, meaning customers that just don't buy much of stuff from Coles. And cluster 2 represents high-price buyers, like premium product buyers, and they're not discount-driven as well. And we can figure this out with the numerical values that we've seen from in the bottom left of the slide. It can the cluster 0 has high discount flags, and the way we calculated it, that's the value of Z, and the way we calculated it is at the right side of the same picture. The formula is like cluster mean minus overall mean. So that's the reason why the value might go in minus as well. The value minus meaning it's that cluster has less of a discount flag, but cluster 0 has more discount flag compared to the overall mean of the discount flag, and it's generating more revenue. And through this analysis, we can also figure out that discount actually impacts the revenue because the person who are more discount driven are generating more revenues, and we can see that through the graph as well. Next slide, please. And PCA just means like we're just concentrating all the features and trying to make it a 2D analysis. Let's say because the more features there are, the dimension of the graph would increase, and it would not make any sense at some point. So just trying to concentrate them and plot them and see what's the actual difference between the clusters that we have built, and does it make sense to make clusters of those data, we do PCA. Next slide. So in our analysis, we have done three clusters, and through the PCA analysis, we can clearly see that there is a huge difference between those three clusters. Let's say cluster 0, which was discount-driven customers, are way further compared to the premium customers and customers that don't buy from Coles. The discount-driven customers are contributing really heavy in terms of revenue. Plus, it makes sense to make three clusters, and we can clearly see that it makes sense to make divide the data into three different groups, because you can clearly see that there's a huge difference between them and how they react to different features. PCA1 and PCA2 just means that it's the concentrated version of all the features. It's not division of features, it's just like concentrated version of all the features. And the point of making this graph is just to see how data are different from each other and whether our clustering makes sense or not. And we can clearly see that there's a huge difference between our clusters. Next slide, please. And this is just the definition of the PCA1 and PCA2, what I mentioned before. It's just a concentrated version of all the variables in the data. And then the point of that graph was just to see if there's an actual difference. Next slide. Yeah, and I can pass this to Saurabh for further explanation.
Thank you, Chandra. Hello again. So let's discuss with the methodologies. So first, we started with the predictive modeling, which basically included two algorithms like linear regression and descent tree regressor for revenue forecasting. And then we started with the clustering process, where we implemented K-means to group products into segments or say clusters. And later we implemented visualization, such as graphs to show trends in categories, brands, discounts, and regions. And later we later implemented evaluation metrics like MAE stands for mean average error, RMSE stands for root mean square error, and R square for model accuracy. Let's continue with the key findings. So here we can see that the top categories of the Coles are pantry, drinks, dairy, eggs, freeze drive the highest revenue, and brands, among which Coles private label dominates revenue, where other brands contribute moderately. And the regions that performed well in terms of revenue are the most states like NSW, Victoria, and so on, and where Northern Territory lags significantly. In terms of discounted products bring slightly higher revenue than the non-discounted ones. And models like both regression models showed very high accuracy, nearly around 1. So these are some of the recommendations for Coles that we would like to explain through our analytics, which are expand private label products, but also promote secondary brands to avoid over-reliance, focus on promotions and stock optimization on pantry and drinks, as these were the products with the higher revenue, and improve sales in Northern Territory through distribution and marketing strategies, or say supply chain management. Use discounts more strategically so that it will help in the greater revenue output, and especially for mid-range products, and prioritize premium products in inventory and tailor marketing to each cluster, which means that we can focus on certain individual or a group of individuals for the better marketing strategy. So to conclude with this analysis, we can say that the analysis shows that data-driven insights can help Coles optimize their operations in terms of marketing, manage inventory efficiently, and strengthen its competitive position in making revenue better. And predictive models and clustering provided clear directions for targeted strategies. That's all about our presentation. Thank you.